Hello and welcome to another video of myself looking at quantum technology websites from different quantum companies, from quantum computing, sensing and communication, and nowadays also other quantum companies space. So today we look at a company which is called Classiq with a Q at the end, and let's check out on their website what they have to offer us. So here we are at the website of Classiq. First of all, we close this down here. It says quantum computing software that enables the design, optimization, analysis, and execution of quantum algorithms. We see a little video here. So there's like a quantum computing programming interface. We see Hadamard transformation, which is like one of the different gates that you have. Then you have this. Here you see the different qubits, and like you have this graphical user interface of creating entanglement between different qubits. Here we see different machines. There was IBM, but also some others of them. Here we see like statistics, a histogram of a count. So okay, looks like there are like various different ways of implementing and different options of using this software for quantum computers. Let's scroll down and see what we have here. So trusted by different company labels. So these are probably users of their software. So Microsoft, AWS, NVIDIA, HSBC, just to name a couple of them. But there are also others, Rolls-Royce, Fraunhofer, KPMG. So a lot of big names down here. Okay, the new way to create quantum algorithms. It's almost magical. Our quantum computing software platform transforms high-level functional models into optimized quantum circuits. Quickly develop circuits with 10,000 or 10,000 qubits and execute them on any gate-based system and cloud provider. So they are cloud agnostic, system agnostic, and they also work on machines of different sizes. That's what I take from this here. That's already quite a big statement. Use our quantum application development software to build internal expertise. Create your own reusable quantum IP. So again, this is on the IP side of things. This time it's not about the, let's say, hardware IP, as in creating specific circuits or creating specific systems, but this time it's on the algorithm side, on the algorithmic side of things. So they offer this interface where you can create your own algorithm, and then it says make sure that you save this IP, and then it's agnostic to different clouds, to different systems. You can also run it on premise, as it looks here. Remote quantum hardware, cloud providers. So that's an all-in-one Swiss knife for quantum computing. So design of novel quantum algorithms with Classiq. So here you have the different ways of designing things. You see, you can write it as a code if you are a software engineer, but there are also ways here to create like these boxes and flows, and basically probably use like a graphical user interface to do that. Okay, what else do we have here? Optimization of novel quantum algorithms with Classiq. So this is like on the side of how to make your code run in a performant way, I guess. So here you see depth and width, and then you see that this is being changed. So I guess this is like the optimization, as in like how many qubits you need, how many iterations you need. Maybe this can help you to optimize depending on specific parameters that you tell it to optimize. Analysis of novel quantum algorithms with Classiq. So you can also create your own algorithm. Well, that makes sense in a novel way. The interesting thing is, I think it looks like you can not only just do the standard gates in here, as in like Hadamard gate or whatever, but you can also do your own algorithmic blocks and put them in there. So you don't have to do everything from scratch again, but you have like packages which you can basically drop in this algorithm line here, in this timeline. That's also a very helpful concept. And then, execution of quantum algorithms via Classiq. So you can probably then just run it on your machine of choice, like quantum program, execute, and then it will run on the cloud and the quantum software that you would like it to run. There's also a community on Slack as it looks, so that's probably also very interesting. Always good to have a community to give each other feedback and also to answer each other's questions. So that's probably good to have. Then let's learn a little bit about the product. So there's a sign up, there's platform. So they have their own platform as it looks, introducing quantum algorithm design, experience a radically better way to develop quantum software. Our platform automatically creates optimized and hardware-aware circuits from high-level functional models. It automates and simplifies the difficult process of creating quantum algorithms. So you can basically focus on the algorithm creation side of things. So you say what you want the machine to do, and then they basically abstract everything away from that, so you don't have to think about like how to compile this on a specific machine, yada yada yada. That makes sense, I guess, to have something like this. Design and code quantum circuits at a higher level. Coding at a gate level works today, but it won't scale when quantum computing algorithms require more than a few qubits. Our flexible and powerful platform lets you focus on what you need the algorithm to do, and then automatically generate the how, a circuit that delivers this functionality while meeting the system constraints. So basically, as I said, you focus on the algorithm, and the way that it's being executed is being taken over by Classiq. Quantum algorithm design limited only by your imagination. Start with our rich library of predefined functional models. That's what we saw before, right? Instead of just applying single gates, you can already do like, I don't know, Grover algorithm on those qubits. And at your own, quickly estimate the required quantum resources and modify their functional behavior as needed. Then let our platform explore thousands upon thousands of implementation options to come up with an optimized circuit to meet the system constraint and work on the hardware and cloud provider of your choice. We've imagined and built the software platform. We can't wait to see the breakthroughs in quantum computing algorithms you'll create with it. So this is really targeting the people that want to actually build software on quantum computers, right? Quantum circuit synthesis that understands your constraints. Okay, so basically, this is now on the other side, right? On the compute provider side, this is taking into account what the computer can actually do, and then translating this into each other. This is probably the value proposition, right? And here, that's a very nice animation. Looks very cool. You can see the different stages. And the value proposition is, of course, you don't have to deal with any of that. It abstracts it away from you. You don't have to even think about which platform you want to use. You just code it in Classiq, and then it abstracts everything away from you and does everything for you. Okay. Let's see what else we have here. There's like white papers. This is from February 2023. There are some more here, 2022, 2021. Then we have some documentation as well. This is now quite flashy, because before everything was in dark mode. That's how I can switch it. Good to know. Now I'm in the documentation. I would like to go back though to the original site. Then we have the Slack community and GitHub. So it looks like things are also pretty openly available here on GitHub. So the high-level quantum modeling language. Okay, so this is about this specific programming language of Classiq and how it works. That's explained here on this GitHub repository. And it's probably like the base package of this, including tutorials, test functions, community. Okay, so this is very much on the programming. Of course, it's not the technology behind the platform, right? The code behind the platform. Okay, then we have solutions here. So the typical things that are being targeted, we see already here. We have finance, we saw HSBC before. There's chemistry and pharma, healthcare, manufacturing and industry 4.0, logistics, cyber, which is, I guess, cybersecurity, energy and networks, quantum hardware, automotive, and aerospace and defense. Then there is also education-wise something targeting academia, research, and grants. So if you, for example, click on this, empowering academic research and education in quantum computing. So there you can probably also get some access to the platform for learning and education reasons. Could also be interesting, right, for a university to have a couple of licenses and to do like a little course on quantum programming and then actually learn on how to program it on this platform, so that you don't have to deal with all the underlying layers of complexity when it comes to, like, I don't know, interacting with superconducting qubits, right? Then here are the actual algorithms and applications. That's also very interesting. So we see here the quantum algorithms, the Deutsch-Jozsa algorithm, Grover's algorithm. That's all like very well-known algorithms from the quantum computing side of things. So like true or native quantum algorithms. We see quantum Monte Carlo, Shor's algorithm. So, and there are even more variational quantum eigensolvers. So this is like all from the repertoire of quantum computing algorithms that are either hybrid or like native to quantum machines. And then here we see as applications, linear systems, probability estimation, machine learning, knapsack problems, hardware benchmarking, Hamiltonian evaluation, graph theory problems, database queries, combinatorial optimization, and algorithm benchmarking. So these are, let's say, the applications that those algorithms are targeting, right? So you see, for example, machine learning with quantum computers, and then below that you have, I don't know, variational quantum eigensolvers or whatever, right? I guess that's how it goes together. Or you see, there is like, I would have guessed that there is also something like portfolio optimization or something, and then you see like quantum Monte Carlo or something like that. But yeah, it is the different applications, and let's click on one of them just as an example. Let's take, because it's very trendy right now, machine learning, quantum enhanced machine learning with Classiq. So harness quantum computing in machine learning. Then we see a lot of explanation here, how it actually works. Key quantum algorithms for machine learning on Classiq. And then we see, as said before, for example, here the variational quantum eigensolvers, but also quantum neural networks, quantum support vector machines, quantum approximate optimization algorithm, and Grover's algorithm. And then, okay, there is something here which also states the applications of this specific algorithm here, right? And then it explains probably how, for example, in finance, healthcare, manufacturing, aerospace and defense, this can be used. So if you are on the software side of things and you always wonder, like, what can I do with a quantum computer? What are the business problems that this might solve one day? I think this could be an interesting place here to actually check out, because it looks like this is really thought through and well documented, as in like what algorithms are there, what algorithms do you need to know about, and then also how could these potentially be applied to industry applications, right? And then we see all these nice, probably Gen AI created avatars down here. That's very cool. So it also looks very appealing from the way that it's designed. Okay, so that's the solutions. Then we have news and insights, which, is also very up to date. So in beginning of June now, we see that here in May, they closed the Series C round for quantum computing software, 110 million US dollars as a funding. So congratulations if somebody from Classiq is watching it. Congratulations for this great success for collecting these 110 million US dollars in funding. Very excited to see how this will probably step up the whole game even further. Let's also quickly check out about the company, about us expanding the art of the possible in quantum software development. So then we believe in quantum. At Classiq, we believe that quantum algorithms should be limited only by ingenuity and imagination, not by laborious gate-level design. That's why we build a software platform that helps quantum teams automate the process of converting high-level functional models into optimized quantum circuits. A quantum revolution. With our revolutionary quantum algorithm design platform, quantum teams can create quantum algorithms that were impossible to create otherwise. Upgrade from gate-level design into a quantum world limited only by your imagination. So this is really like focusing on bringing you from this more or less tedious base level work step up into thinking about the quantum algorithm side of things without having to take into account the other stuff, the lower level stuff, right? Here we have the whole team. I guess this is like the leadership team, IDE, core technologies team, quantum applications team, growth and community, quantum algorithms, product, marketing, business development, operation, and people team. So a lot of people already working there. And then, of course, now I hope with the new funding, they can even hire a couple more. And then there's offices in Tel Aviv, Boston, and Tokyo. With that, I don't want to make it too long of a video today, but that definitely looks like a very exciting company to me. This is also a different perspective than what we might have seen before with the companies that were looking more on the hardware side of things. This is purely on the software side of things, but still very much focused on the quantum computing part of it. So algorithms and not sensing or communication side. Very interesting, definitely worth checking out. As I said, especially probably the algorithms and applications part is to me very interesting. And if you want me to actually go through this in a little bit more detail, let me know down in the comments below, and then we will make a video about this. And with that, as always, make sure you're hydrated. So get yourself something to drink and watch the next video maybe from this series. And yeah, see you in the next one. Bye bye.